Hello everyone, I'm Andrew Holliday, the Applications Engineering Manager here at Phase 3D. Today, I'd like to show you a feature within Fringe Operator, our premier software tool for visualizing the data generated by Fringe Inspection. Fringe Inspection is our in-situ inspection product that uses Fringe projection, a technology that uses structured light to measure every single layer of your additive process. Today, we will be focusing on laser powder bed fusion. But the technology is applicable to other powder bed-based additive manufacturing techniques, including binder jet. Today, we're going to be looking at our quality chart software feature. So let's launch directly into Fringe Operator. Now, in Fringe Operator, you can see that we have three individual panels. On the far left-hand side, we have our 3D visualizer. In the middle section, we have our 2D height map view. On the far right-hand side, we have our quality chart and the anomaly table. Now this far right-hand side is where we're going to be taking a look today. So first off, the quality chart looks at each individual layer of the build and then shows the anomalous volume per layer. As you can see, I'm currently on layer 124. However, using the quality chart, I can quickly skip to layers of interest. For example, I'll click directly to layer 154, which shows an anomalous area of 537 millimeters squared and an anomalous volume of 49 millimeters cubed. So I can go straight to that layer, and in Fringe Operator, the 2D height map view then reflects the layer I've selected. I can see here that this layer had a number of anomalies going on. First of all, we had a recoder hop, which is where that recoder hits the part, raises up, then drops down to the powder bed, as seen with this vertical anomaly. Additionally, we had a recoder streak down at the bottom, as seen with this horizontal line going through the powder bed. And we also had powder dropping, which is where excess powder that was trapped on the back of the recoder after making impact with the part actually falls directly onto the powder bed. So really, what this quality chart is allowing us to do is to quickly visually see which layers are good and which layers need attention. Similarly, I can skip to other layers that show high anomalous volume, such as layer 279. In this case, we see a lot of out-of-plane distortion from swelling parts, and again, another recoder hop where the recoder made impact with that part. Now, if I don't want to view this information in chart form, instead I want to view it in terms of a table, I do have this anomalies tab over here on the far right-hand side. When clicking the anomaly tab, I can then see in tabular format all of the individual anomalies that were detected by Fringe Inspection. Now these anomalies are broken down into three major categories. The first is those recoder hops, the second is those recoder streaks, and the third is a general anomalies category. Now using the anomaly table, what I'm also able to do is filter or set thresholds to the anomalies I want to view in this list. And I can threshold these based off of the average depth of the anomaly as well as the minimum volume. This way I can ensure that only the anomalies that I care about are being shown within this anomaly table. Thank you, and I hope you enjoyed the overview of our quality chart and anomalies table feature. Of course, if you have any questions, feel free to reach out to me or connect with us via LinkedIn or travel to our website. Thank you.